Alright, this is a DSE past paper question on three-dimensional problems taken from the year 2012. Well, I try to put down all the corresponding information in respective colors. So first of all, it's a right pyramid. Right, right pyramid means all the four red lines, they have the same length with a square base. Right, square base means all the pink lines, they have the same length, 20. Alright, and the green angle is 72. Now, because it is an isosceles triangle, all the faces, all the triangular faces, they are isosceles triangles. So all the angles, they should be the same. So all the green angles marked here, they are all of them, they are 72 degrees. Right. So on one of the surface VAB, we draw the purple line PB. Right, we draw this line here, so that the angle is 60 degrees made with AB. Alright, so the angle VBA, this one is 60 degrees. So we want to find the length of AP. Alright, we want to find the length of AP. So we look at this focus triangle. Alright, we need three pieces of information. So happen we have all three pieces of information. We have the we draw the line P here. Alright, we have the green angle 72, right? The pink line 20 and the black angle 60. So we can use ASA sine formula in triangle APB to do that. Alright, I'll leave it to you. You may pause the video and see how could you use the ASA cosine formula to get the length of AP. Alright, now after you finish it, I think I can reveal you the answer. The answer to this one is 23.3 cm. Alright, let me give more accuracy in digits. Alright, so that's 23.3 to 3 decimal places. Alright, so that is the AP. Simple enough, right? 2 marks, fair enough. Now, the difficulty is in part B. Alright, in the planes PBCQ, PBCQ will be this trapezium. Alright, and the ground and the ABCD, the ground level. What is the angle between them? So angle between planes, we draw the common line. BC is the common line between them. Alright, BC is the common line between these two planes. On BC, we draw perpendicular, one of them in green, the other in pink. Right, so let me call this point Y. Alright, let me call this point Y. So from Y, we draw the perpendicular, the green line, all the way to P, this line. Alright, this line. Alright, we draw the PY, which is perpendicular to BC. Alright, and also we draw another line XY, which is perpendicular to BC. Because it is a square base, right? So XY should be the same as AB. So anyways, we draw the plane line. And the angle between the two planes will be angle alpha. And that is the angle between the green line and the XY pink line. Alright, so this is alpha. Alright, so let's see how much do we know about this PXY triangle. We know very little about this triangle. We only know that this is 20. This is it. Alright, we need to find more pieces of information in this focus triangle in order to get the angle alpha. Alright, so at the end we decided to use the triple S cosine formula. Our plan is to use the triple S cosine formula in triangle PXY to find alpha. Alright, to find alpha. So that means we need 3 lines. Now we got only one. We have the 20. We need the yellow line and we need the green line. Alright, so now let's look at the plan. How do we find the yellow line? The yellow line is easier because we know this angle PAX. We know this PX is 13. We know this angle is 72 degrees. Alright, so we can use the sine ratio because there's a APX is a right angle triangle. Alright, so in step 1, in triangle APX, we can use the sine ratio to find the yellow line PX. Alright, so we have PX. Alright, we have PX. We have 20 cm, the pink line, and PX. Now all we need to do is the PY. Now PY will be over here, right? The green line. Now the green line is challenging because we have very little idea about this PQBC trapezium, right? Perhaps we know BC. BC is 20, right? But that's all. Alright, that's all. Do we know the purple line? We know the purple line in the triangle APB. Alright, we can use ASA in triangle APB to find the purple line. Alright, we discover the purple line. Now you have paused the video a bit and see whether you can find the purple line. Alright, because with the purple line we have this one, so it's one step closer to the green line. Alright, so you may want to pause it now and see if you can do it. According to my calculation, PB will be 25.59546. I made a mistake in AP. AP is not 13, I'm sorry. AP should be the answer taken from here. It should be 23.3, alright? AP should be something like this, sorry. So the answer in PX, alright, I missed the answer PX here. You use a simple sign ratio to get PX. And the answer to PX is 22.17. Alright, the answer to PX is something like this. Alright, so now we have the purple line. What else do we need in order to find the green line? We have the purple line now, alright? What else do we need to find the green, alright? Well, now, this is the difficult part in this question, right? Now, we need the part BY. We need the part, the orange one here, BY. But if you look at the diagram here, the part BY is the same as the part AX here. Alright, so in the step 3 of the calculation, we try to look at BY. BY equals to AX, and once again, AX, we can use the cosine ratio. That is PA cosine 72 degrees. That is how we get the orange line. Alright, you know, this is a long way from the original data, so we have to do it step by step. Alright, now that we have the purple line, we need the orange line. The orange BY is the same as the orange AX, and the orange AX we can use cosine ratio to help us do that. Alright, and it turns out AX or BY equals to 7.2023, something like this. So finally, you can use Pythagoras theorem in triangle PBY, alright, to get the length of PY. Alright, you may want to pause it again to check your own calculation. My answer is 24.56123. Alright, something like this. So now you have PY is 24.56123. You got the XY 20. You got the yellow line. What's the yellow line? Is 22.1663. Alright. Now you have all 3 pieces of information. So you can use triple S cosine formula. That is the last step. Alright, we use triple S cosine formula in triangle PXY to get alpha. So the final answer, alpha is 58.6 degrees to 3 7 figures. Alright. It's a long plan. Alright. If you look at the first step, we get the yellow line. Step number 1, we get the yellow line. That is part B1. Alright. Step 1, we get the yellow line. Step 2, we get the purple line. So this is it. And then step 3, we get the orange line. Purple and orange, we can use Pythagoras theorem to get the green line. With the green, the yellow, and the pink, we can use triple S cosine formula to get alpha. This is the plan. Alright. And then if you realize the plan, you arrive at the answer of alpha being 58.6. Alright. So that's why it's worth 6 marks. Okay, there's also a part B2. Part B2 is the beta is the angle between the line PB, the purple line PB here, and the base. Alright. So first of all, we have to identify the angle, where this angle is. Alright. So the angle between the line and the plane, we drop the projection of point P to the ground level. Alright. And we join that to point B. We discover that beta will be the angle here. Alright. Beta will be the angle between the purple line and the projection on the ground. Alright. So I think it will be easier if you watch it from the top. We have the idea that if you have the same height, then the further the angle is, the longer. The further the angle is, the smaller it is. So if you look at the two angles, alpha and beta, you discover that alpha actually is further away. Am I right? The angle alpha should be further away from here, whereas the angle beta will be closer. If you put them together, you discover something like this. Alright? They are not on the same plane, but if you compare, alright, the purple line is longer than the green line. I think it shows on the calculation. The purple line is longer than the green line. So we have the purple line is PB, right? It's longer than the green line PY. Alright. And what else do we know? We know that sine alpha will be the height divided by PY. Alright. The height being the height of the point P, alright, this H. So sine alpha will be H divided by PY, which will be smaller than H divided by PB. Alright. Am I right? Because PB is longer. So H divided by PY will be smaller than H divided by PB, and that is sine beta. Alright. We know that for sine function, for acute angle, the larger the angle, the larger the sine ratio. Therefore, we know that alpha will be smaller than beta. Oh, I'm sorry, I made a mistake here, alright? PY should be larger than PB. Sorry, alpha should be larger than beta. Alright, sorry, I mixed up the coloring. So let me put it better in this way, right? So PY comes first. PY is smaller than PB, right? That's much better. Alright, so sine alpha will be greater than sine beta, and hence alpha is greater than beta. Alright, so that is the explanation. Okay, so that is the 2012 DSE past paper question.